Okay, so today we're going to look at infinite limits at vertical and horizontal asymptotes. So just a couple reminders from things that you might have learned in Algebra 2. We're going to look at functions where we're going to pay attention to the power that they have. And if we are looking at a power that is even, such as x squared or x to the fourth or x to the sixth, this example right here would be y equals potentially x squared. So if we're looking at a power where your exponent is even, you're going to have what would look like a parabola. And sometimes that parabola opens up, or maybe even it opens down. So in Algebra 2, we call this end behavior. So what we're investigating is when x is approaching negative infinity. Negative infinity would move away, going in the left direction from the origin. And as my x value goes left, we can see that my y values are headed either down, or again, as x goes left, we see my y values are going up. So depending on whether your graph opens up or whether your graph opens down, where your y is headed will either be positive or negative infinity. Now, what's nice about any even power is that if your negative infinity side is going positive, your positive infinity side will also be positive. So whatever sign you use for one, you will use for both. Now, on the flip side of this, if your exponent of your power function is odd, such as this function would be x cubed, you're going to end up using both of them. You can see that on my left side, which would be a description that x is going towards negative infinity. You can see that your y values are headed down towards negative infinity. But as my x value goes more positive towards that positive infinity side, we can see that my y values are headed up towards positive infinity. So in an odd function, your signs will one be positive, one be negative. Now, they don't always necessarily go in that order. Again, if I asked you guys to take f of x and I said negative x cubed, we would start positive and we would go negative. So the limit as x goes towards negative infinity would actually be positive infinity. Again, limits are, I'm going to give you the x, you give me the y. And the limit as x goes towards positive infinity of this function would be negative infinity. As my x goes towards positive numbers, my y value is going down. And there are going to be times, you guys, that we pay attention to the horizontal axis. The horizontal asymptote. And there might be other times where we pay attention to the vertical asymptote. When we are doing limits at infinity, we pay attention to the horizontal asymptote. Okay? We pay attention to the horizontal asymptote when we're doing limits towards infinity. And what we can see what's happening in my graph as my x value is going towards negative infinity, my y value is approaching that horizontal asymptote. And as my x value is going towards positive infinity, again, we are approaching that asymptote. And even if we have a function that has or we can see that they both approach that same vertical asymptote, wherever that horizontal asymptote is going to be when we're doing end behavior is what we're focused on. So back in Algebra 2, they talked to you guys about situations when you have a function in a numerator and a function in the denominator. And we said if the degree of your numerator was less than the degree of your denominator, okay, so your numerator had a smaller degree. When I say degree is your highest power. Okay, so if I give you that example, the degree of this numerator is 3, where the degree of my denominator would be 4. So if my denominator is bigger, we call this bottom heavy. Your horizontal asymptote will always be at 0. So your limit as x goes towards positive or negative infinity is always going to be at 0. Now on the flip side of this, if we do something that's called top heavy is when the degree of your numerator is larger than the degree of your denominator. Then your limit is either going to be at positive infinity depending on what your graph looks like, or it could be at negative infinity. So my best suggestion whenever you have a top heavy graph is to actually look at the graph, and we'll do one of those here in a moment. But if you have a situation where the degree of your numerator is equal to the degree of your denominator, then your limit is always going to be at your leading coefficients. Your leading coefficients. So this numerator has a leading coefficient of 1, so the limit of that function would end up at 1/3. That leading coefficient is where your horizontal asymptote will be. So we're always looking at the horizontal asymptote today. So this top heavy, bottom heavy, or equal degree is going to be pretty key in our next few problems. So looking at this first scenario, I see that my degree of my numerator is a 2, as well as the degree of the denominator. So this limit, this horizontal asymptote, will be at 5/3. This next example, I can see that my top power is 1 and my bottom power is 2. That bottom is bigger, so we call this bottom heavy. So I will have a horizontal asymptote at 0. So my limit as x goes towards infinity will also be 0. In this next example, we have a situation where I am top heavy. So top heavy, I told you guys to take a look at your graph. Now, on the right-hand side of my screen here, I already have that graphed, and we can see that as my x moves towards positive infinity, so we have to pay attention to what direction our graph, our limit is asking us to look. So as my x is moving towards positive infinity, I can see that my y values are also getting bigger, so my limit would be infinity. Now, had I changed that question and I said, what's the limit as x goes towards negative infinity of that same function? We can kind of see the other side of this graph. As x goes more negative, my y value is also getting negative. So on any top heavy, I highly suggest that you graph it. On our next question, what sometimes happens is kids don't pay attention to the fact that that denominator is not written in descending order. So my suggestion would be to rewrite it in descending order. And then you guys can see that the degree of my numerator is equal to the degree of my denominator. So my horizontal asymptote will happen at those leading coefficients, and I can reduce. That would be my limit. I'm bottom heavy. Bottom heavy will always have a limit at 0. And again, on this next one, I am bottom heavy. So that limit is also at 0. That horizontal asymptote will be at 0. Looking at this next example, I have a vertical asymptote at 3. We talked about vertical asymptotes yesterday. We talked a lot about holes, but we also have looked at situations where I'm investigating 3. 3 is an issue because 3 would make my denominator 0. So this would be called a rational equation, and we have a vertical asymptote at 3. Why are we looking at the vertical asymptote this time? Because that is not an infinity symbol. So now we're going to look at the vertical asymptote. And if I kind of re-sketch this, I have a vertical asymptote at 3. And I can see that my graph also has a horizontal asymptote at 0 because I'm bottom heavy. But I'm focused in here at this vertical asymptote at 3. Now this negative sign, remember, says look on the left side. So as I approach that vertical asymptote on the left side, I can see that my y values are headed down. So that would be a limit of negative infinity. If I take this exact same graph and I investigate this, as the question says, on the right-hand side, my right-hand limit is going up. So this would be positive infinity. Now, as you look at this situation, and on my left side I went negative and my right side I went positive, because they're not the same, this limit does not exist. And last example, we can see that here at -4, this is the graph that we're looking at. I have, again, a vertical asymptote at 4. I'm not looking at the horizontal, although there is also a horizontal at 0 because I am bottom heavy. But I want to do the exact same thing. This asked me to look at it on the right-hand side. On the right-hand side, I am headed towards positive infinity. On the left-hand side, I am also headed towards positive infinity. And because my right and my left are headed in the exact same y direction, my limit at -4 would be infinity. Your homework today, you guys, is just page 12, and when in doubt, graph it out.